A very good morning, friends, and welcome to my channel. It's Shinde's Chemistry Mastermind, and today I come with a new video which is very important for general organic chemistry, CBSE first year, in NEET examinations and in IIT mains. Many questions are expected, okay, regarding this topic. So let's see, friend, what is Markovnikov rule. So here generally, so many questions are expected from this Markovnikov rule, which is concerned to unsymmetrical alkenes. So in first year we have hydrocarbons. In hydrocarbons, alkanes, alkenes, and alkynes preparations are there, and preparations and its properties. So here is electrophilic additional reactions, okay, which alkenes undergo electrophilic additional reactions with hydrogen halides and form their products. So here this is the Markovnikov rule. So we have to understand the concept of Markovnikov's rule. So just here, so the Markovnikov rule is proposed by Markovnikov in the year 1869. So he is regarding to the unsymmetrical molecules. He explained the properties of unsymmetrical molecules. So generally, before going to start this session, so we have to know what is symmetry and what is unsymmetry. So generally, in carbon compounds which have double bond. So here in alkenes we have carbon-carbon double bonds. So here, free rotation is not takes place, and if the alkene is symmetric, so how can we know symmetric? So if double bond carbons of same side, if the same ligands are attached to these carbon-carbon double bonds, so this type of alkene is called symmetrical alkene. If same type of ligands are not attached to the same side, so it is called unsymmetrical alkene. Okay, got it? So now here for unsymmetrical alkenes, if we discuss about additional reactions in for unsymmetrical alkenes, electrophilic additional reactions. So we have to follow Markovnikov rule. So what the Markovnikov rule is? Let's see. So in electrophilic additional reaction of unsymmetrical alkenes, the negative addendum or X minus molecule attached to carbon atom which possesses less number of hydrogen to it. Okay, you understand this one? So here now an unsymmetrical alkane is there. So if the unsymmetrical alkane is undergoes electrophilic additional reaction, so here the negative part, so here negative ion, so here we call it halide. So negative ion is attached to the carbon, the which carbon have the less number of hydrogens. You remember it, the carbon which is present in alkene and form less number of hydrogens in which carbon. So this this negative ion is attached to this carbon which have the less number of hydrogens. So this is a Markovnikov rule. So according to this rule, if you see the reaction here, so 1 propene is the example here. So 1 propene is not a symmetrical alkene. This is unsymmetrical alkene. So 1 propene is undergoes electrophilic addition reaction with hydrogen bromide. So here the hydrogen bromide is there. 1 propene react with hydrogen bromide, and there will be chance to form carbocations. So here the first one is primary carbocation. See, CH3 CH2 bond CH2. So this one is a carbocation is there, and secondly secondary carbocation is there. So there is a possibility to form two types of carbocations, primary and secondary. So as per the unsymmetrical molecule is concerned here, and for unsymmetrical alkenes, here the secondary carbocation is more stable. Secondary carbocation is more stable, compared to primary carbocation. What do you mean by primary carbocation? So here this is the first carbon. Okay, for this first carbon, if the cation is present, okay, if the charge is present on this carbon of first carbon, so this is called primary carbocation. And if the charge, positive charge is, okay, exists on second carbon, okay, it is called secondary carbocation. So here for unsymmetrical molecules, secondary carbocation is more stable compared to primary carbocation. Okay, but for symmetrical molecules, primary carbocation is more stable compared to secondary carbocation. So this one is an important bit for NEET exam. Okay, remember it again. Okay, and for unsymmetrical molecules, secondary carbocation is more stable compared to primary carbocation. It is because according to the, okay, Markovnikov's rules, okay, these, okay, halide ion is attacked, okay, to the carbon which have or which possesses less number of hydrogen. So here this is secondary carbocation have less number of hydrogens on secondary carbon. So here the negative ion, which is halide, which attacks and form the product. Okay, so let's see the reaction mechanism here. So this is important one. So here firstly, okay, hydrogen halide. So here is hydrogen bromide. Okay, ionized and form, okay, H plus and Br minus, these are ions. Okay, in step second, so we have one propene. So this is unsymmetrical alkene. So this one propene is, okay, react with H plus ion. So this one is H plus ion, which is electrophile. So here the electrophile is initiating the reaction. Okay, electrophile is initiating the reaction, and the reaction is depends upon, okay, electrophile. The reaction is depends upon concentration of electrophile, and the reaction is carried in a slow way, so that, okay, this is rate determined reaction, and the reaction itself is called electrophilic additional reaction. So here in second step, this propene, okay, react with electrophile, right, which is slow step, and form secondary carbocation. Already we are here given the examples. Primary carbocation is a less possibility, but here formation of secondary carbocation is a more possibility. So here we get the secondary carbocation, which is more stable. In third step here, okay, secondary carbocation is, okay, attacked by nucleophile. Already we discussed here secondary carbocation which have the carbon which have less number of hydrogens. The nucleophile is attached to this carbon, positive carbon, okay, and, okay, form the product. So here the product is 2-bromopropane. What is the product? 2-bromopropane. So alkenes are react with alkyl halide and form, okay, alkene react with, okay, hydrogen halides and form alkyl halides. So this type of, okay, reaction for unsymmetrical alkenes is, okay, understudied by Markovnikov rule. So followed by the Markovnikov rule. So here if you see order of reactivity, this one is also main important question they are asking in NEET exam. What's that? Order of reactivity. If we see the order of reactivity of halide ions, so here HX means hydrogen halides. You see hydrogen iodide, hydrogen bromide, hydrogen chloride, all these. So here the order of reactivity of hydrogen halides are Hi, HBr and HCl. So firstly, okay, hydrogen iodide is more okay, reactive, and then hydrogen bromide, and finally hydrogen chloride. So hydrogen chloride is less reactive, but hydrogen iodide is more reactive. Okay, so here Markovnikov rules is explained or followed for unsymmetrical alkenes, right? So here we have to know some important points here. So first formation of secondary carbocation, and firstly electrophile is initiated the reaction, so it is called electrophilic additional reaction, and after that secondary carbocation, okay, react with nucleophile form major product. So here the secondary alkyl halide is a major product according to the Markovnikov rule. So friends, so here you practice well, okay. So more questions are expected from this. So what type of questions they are asking? So which type of reaction is, okay, according to the Markovnikov rule. So this is the, okay, electrophilic additional reaction. Which one? Electrophilic additional reaction is there. Next order of reactivity followed by alkyl halides is from hydrogen iodide to hydrogen chloride gradually decreases. So it is more, okay, reactive hydrogen iodide and less reactive hydrogen chloride. Okay. Now here the secondary carbocation is a major product, forming major product, and if the symmetrical alkene is there, so the major product is primary alkyl halide. Okay, primary alkyl halide is a major product if the alkene is symmetrical, and if alkene is not symmetrical, it is follow, okay, Markovnikov rule. Okay, for thank you for watching this video. If you like this video, please share, subscribe, and we come with many more videos in further classes. Thank you very much, one and all.